Okay. So a student asked me a question about a rocket-powered hockey puck on a frictionless surface moving according to some velocity in the x direction and some velocity in the y direction. And you notice that the velocity is in the x is power positive at first, and then goes to zero and then becomes negative, whereas velocity in the y direction is just always increasing upwards. So, okay, to answer questions like these, we're being asked what is the magnitude of the puck's acceleration? How far from the origin is it at various different times as well, right? And we're also told that the puck starts at the origin. So for the very first one, right, the magnitude of the puck's acceleration, well, acceleration in the x direction is just equal to dvx dt, and similarly for y, dvy dt, right? So what this is saying is this is just the slope of the graph on the left, and this is the slope of the graph on the right. So just doing a quick sanity check here, right? It's just this is essentially high school or middle school algebra. You can just read off the slope from the graph, figure, y is equal to mx plus b, figure out what m is. And similarly for over here, right? Whatever slope it is will be your vx or vy values respectively. So the idea here is your total overall acceleration is going to be acceleration is just going to be the square root of its components, ax squared plus ay squared, right? So you can see how reading off the values from the graph, you should just be able to plug them in right here, plug those slopes in. Yeah, plug those slopes in, and that should get you what you want. So now it asks, how far from the origin is the puck at 0 seconds? Well, you can just read that off from the problem, right? The puck starts at the origin, right? So that should tell you all you need to know right there. But then it asks you how far the origin is the puck from the origin at 4 seconds or 9 seconds or however other many seconds, right? And to answer that, you should be able to figure that out just by taking a look at the area under the graph. So what makes this just a little bit more complicated is, let me put it this way. So if the position at x, is going to be equal to the integral of vx dt from 0 to, let's say, 4 seconds or whatever time you want to find. Well, there's also a constant of integration, but we happen to know that's 0 because it starts from the origin. So similarly, y is equal to vy dt, again, plus 0, from time 0 to whatever time we want to find. Let's say it's 4, right? So the idea here is basically you're going to want to find the area under the curve from 0 to 4. And you can do this either by integration or by just recognizing that this actually isn't too bad and probably doesn't require integration if you don't want to. And instead, you can just figure out what the area under the graph is. Yeah? But the idea here is that because the position is the integral of velocity, for whatever time period you want, the area under the graph of velocity is the change in position. That's the whole idea behind derivatives and integrals. So basically what I'm saying is you can figure out what the change in x is, or the position of x is, and then you can similarly figure out what the position of y is. And then finally, you can use d is equal to the square root of x squared plus y squared in order to figure that out. Yeah. So for t is equal to 4 seconds or 1 second or 2 seconds or 3 seconds or maybe 5 seconds, this shouldn't be so bad because the area under the graph is all positive, right? And hopefully that should make some sense. The area under the graph is positive, but then it becomes a little bit more confusing because if you're looking for something higher, let's say 7 seconds, it becomes just a little bit confusing because, excuse me, because for Vx becomes negative. So then some of this area under the graph sort of has a negative component. And the idea here intuitively is that this amount here is going to cancel out with some amount over here, right? Whereas for Vy, it's all still going to be positive. Yeah, so what is this basically saying, right? Let's just think about what's happening with Vx. It's basically saying, okay, if the particle starts at 0, it's going up until, slowing down a little bit up until it gets to t is equal to 5 seconds. And then it sort of turns around and starts going backwards, right? So at like t is equal to 7 seconds, it'll be back around here, right? So this is the x direction. So this is basically what area under the curve is telling you. It's telling you the change in position because it can take into account both positive and negative velocities. So basically what you're being asked to do is either just integrate the expression directly from, how do you put it? You can either integrate x is equal to, I don't know, 0 to, what were we being asked to find, like 7 or 9 or whatever. You can integrate the y is equal to mx plus b equation, dt. Like if you had some expression like 10x minus, excuse me, if your equation for the line was like 10 minus x, right? You could just integrate this directly to figure out what the change in, excuse me, if you're, what was this expression? This looks to me like it's going to be 10 minus t, right? X is equal to 10 minus t. X is equal to 10 minus t. You can just plug this right in and integrate it. So that way you don't have to think if you don't want to. And then plug in the bounds 0 to 7 in order to figure that out. Or you can look at this just by saying, okay, let's let this area on the left over here be positive. And let's calculate this area separately and let it be negative and add those two up. And you should see that you'll get the same answer either way. But yeah, that's the idea. Go ahead and do that problem, and it should work out perfectly nicely. You should get a reasonable expression for the distance from the origin. Again, y is not so complicated for the second part because it's been moving in the positive direction the whole time. So again, you can use an integral to express it, right? And just what's the equation for y going to be? It looks to me like y is just equal to t, I suppose. Y is equal to t. Or sorry, rather vy is equal to t. Sorry about that. But yeah, that's all you're going to do from 0 to 7 or whatever time you want to find. Okay, great. I hope that clears it up.